So hello everyone and welcome to the final event and the pitch competition of the amazing Intelligent Energy Lab Hackathon. It's an honor to greet you all live again from Vilnius, the capital of Lithuania. Today our stream reaches almost 4 continents of the world, since we have 16 different country participants in this hackathon. My name is Andrius Milinavičius and it's my pleasure to support you guys on your journey to the Intelligent Lab Hackathon throne. For those who are just joined our stream, today we're having the last day of the Intelligent Energy Lab Hackathon. Our hackathon is happening together with the annual Energy Tech Summit event. Intelligent Energy Lab is an open platform that invites and involves other companies, universities, institutes and associate structures that care about efficient energy use, sustainability and the modern city energy sector. Our goal is to focus on managing energy more efficiently than ever before. I bet everyone is really curious, how did the hackathon happen, keeping in mind that we had teams from absolutely different time zones. And we do have our precious mentors present today at the moment, online and offline. I'd like to invite on the stage one of the mentors that was participating in this hackathon, Tomas Nickus, mobility expert and board member at Connecting Services. Thomas, hello. 3 full days of action, development and building the impactful solutions. What are your impressions after these 3 days? Maybe you could share something with us.
Yes, thank you. I'm glad for the opportunity to join in this event. It was my first time when hackathon is online, and I'm very happy for that. I'm happy also that everybody thinks green and everybody wants a better environment.
Okay, we had 12 different challenges. Were there some specific topics that were super popular and other a bit less, or teams actually distributed among all of the challenges?
Yes, we have a lot of teams. In my session was 3 teams. They things different, and they want better future for us. They want a green environment. They don't want transport, the cars, and everybody think about the same.
Okay, understood. And do you already have your favorite team that you're going to vote for?
No, I don't have. I want to see all the presentation.
Okay, and of course, for everyone to know, Thomas is also a jury member, so he can't have any favorites, and he has to be super transparent in this. Thank you so much for your answers.
Thank you.
Thank you for being with us. And now I'd like to talk to Neringa Dubauskienė. Neringa is a lecturer at the Kaunas University of Technology. Neringa, what are your impressions after these 3 amazing days of hackathon?
Hello, thank you very much for letting me be a part of this amazing event. And I'm very proud of the teams that I had the pleasure to mentor. They were actually quite enthusiastic, interesting, had some very interesting ideas, and I wish them all the best in the future, because I think all of those projects are worth to be developed.
What were the biggest challenges that you saw the teams had to overcome during the 3 days? Maybe you could share some small but interesting story.
Well, I think the biggest challenge for all the teams is communication between themselves, as well as communication to the mentors and the commission that will evaluate them. So don't forget that, because most of them focused on the technical challenges and the technical side of the projects. But as you all know, it's not the only part of the project that you have to think about. So thinking how you will earn money from the project eventually, what kind of use could it be to the city, to the people, or to the commercial side of it. It's also very, very important.
Absolutely, absolutely. I would love to double up on this. And do you have your own favorite?
Yes, I do, but I would like not to disclose it in case somebody will decide based on that. So I'll keep my favorites to myself, and I will wish best of luck for them in the future as well.
Thank you so much, Neringa, for your kind words. And also, today we have Renatas Kandratas, Junior Account Manager at the Blue Oceans PR. Renatas, hackathons are not new thing in the world, right? But hackathons in online, it's a bit new, and it's only for a few years that we are getting used to that. Even today, we have a lot of teams from all around the globe, right? What are your impressions from work online? Is it a simple thing to do?
Well, from my own experience in hackathons, I was a participant once. So there's a completely different drill and experience when you are working with the team alive. But this version online hackathon is really a good experience to try this remote work, to try this remote business development, if I could say so. And it is quite a unique experience, which I think helps personally and in the team to adapt to the changes and to still be efficient and reach your goals. So I think online hackathon is quite a solution during these times, and I think it is quite a good idea.
Are you confident that it's possible to actually build an impactful solution while working in a very much remote team across the world?
Well, from my own experience, I'm team manager in one of the youth NGOs, and I'm manager of an international team that is working fully remotely across Europe, and we managed to achieve our goals. So I think in this case, it is as well. The main point is to have a trust to each other, to have a clear plan and dedication, basically, to your goal and to your team. So I truly believe that these teams, if they chase their goal and they really want to achieve it, they will.
Absolutely. Thank you so much, Renatas. Thank you for your answers. And thank you all mentors. Thank you, dear mentors. Let's now move to the part that everyone is really waiting, the final pitches. But before we move to the pitches, allow me to present you the general rules of this pitch competition. Today, we're having 15 finalists that reach the final. All of the teams managed to participate in all of the checkpoints. They got very positive, of course, feedback from the mentors, and they finally reached the final. The pitch will consist of 2 parts, 5 minutes for the initial presentation of the hackathon results, I mean the pitch itself, and 3 extra minutes for the Q&A from the jury. The jury can ask anything they want, of course, and hopefully they are not going to be so fierce today, because we're all building only the beautiful, good future here, right? So why be fierce? As for this pitch finals, we will be strict with time. So please, everyone, have in mind that the clock is ticking and focus only on essential things. And by saying essential things, I mean the evaluation criteria. Everyone knows what the jury will be evaluating. Our jury today will have to evaluate each and every project on 8 different criteria, and I'd like to announce all of them. First, of course, as usual, clear problem definition and relevance of the problem. Second one, technical and financial feasibility of the proposed solution. This is exactly what our mentor was mentioning. Not only the good idea, there should be some business behind it, right? Third, progress made throughout the hackathon. Fourth, go-to-market strategy. Fifth, quality of the pitch. Sixth, team and its potential in the future developing the project. 7, care of the world. And 8, impact on Vilnius city in the smart energy sector. Seems pretty clear, right? Allow me to present our jury members. They have a really tough job to do today. Okay, can I invite on the stage Paulius Martinkus, Chief Strategy and Business Development Officer at Vilnius District Heating Company. Applause for Marius. Paulius, sorry. Also, today, together with us, we have Eglė Radvilė, author of Vilnius Digital Strategy, Digital Train Board, and Harvard Digital Program member. Hello, Eglė.
Hello, everyone.
How are you doing today?
Perfect.
Perfect. Ah, sounds very good. Also, Tomas Nickus, mobility expert and board member at Connecting Services. Hello, Thomas.
Hello again.
Feeling great?
Yes.
Absolutely. And Rokas Pečulaitis, founding and managing partner at Contrarian Ventures. Rokas, how were the few days that you were?
Good, very good.
Anything specific you'd like to tell us?
No, I think we're going to see some good pitches today, so I'm excited to see that.
It's not common to have 15 finalists that are actually doing an impactful solutions for the city, right? Amazing. Also, online with us, Peter Anderberg, founder and CEO at the Heat Academy. We will see him shortly on the screen. And last but not least, the last jury member Marius Aleinikovas, Deputy Director for Institute and Forestry Activities, Lithuanian Research Center for Agriculture and Forestry. So, dear jury, it's nice to have you here. I believe everyone is in a very good shape, in a very good mood, because we will see 15 amazing startups pitching. So let's move on. 15 teams. I'd like to present each and every team, just for everyone to know the lineup. I will, of course, be telling you guys that you have to get ready. So, first team is going to be WH2E. The second one, Re-Energy United Solutions. The third team Energy Pro, the fourth team Heavy Metal, fifth Matomai, sixth one Vilduja team, seven EDF Les Survoltes, the eighth one RNR, the ninth one Duomenų ir kompetencijų centras, V-Planas. This team spent a lot of time thinking of the name of the team, of course. The 10th one B Group, the 11th one Netterštukas, the 12th one ASTIO District Monitoring, the 13th one OTC, the 14th one Drive Less, and the last but not least Vilnius Žiburiai. That's the name of the team. Okay, guys, let's move on to our first pitch. 5 minutes for the pitch and 3 minutes for the questions from the jury. So, the team VH2E, 5 minutes for your.
Hello, my name is Martin and we are Waste Heat to Energy, and we convert waste heat into electricity using a cost-effective, mass-producible small heat engine. Everybody knows it, we all see it every day, wasted heat everywhere. Also in Vilnius, you can see a lot of heat that cannot be used today because of the lack of technology. And most of this heat is between 50 and 150 degrees Celsius. And the highest potential is below 200 degrees Celsius to be reused into electricity. So today there are already heat engines, but these heat engines are super large and super costly, and they are very inconvenient to install. And now what we want to do, we want to have small, low-cost heat engines for everybody that have like the same form factor as a normal heat pump. And the potential customers are house owners that have solar heat, district heat. Every heat-based process can become more efficient with this technology. Power plants, geothermal heat, and also data centers are a big market for us. And we want to scale by not making one big unit, but to sell multiple small units. And first we want to concentrate on energy prosumers, solar heat, district heat, and wood pellet heating. So we convert heat into electricity. That's what we do. And the focus range is under 200 degrees Celsius. The payback time for this machine will be between 3 to 5 years, and it will produce 1 kilowatt of electricity and cost around 3,000 euro. And how does it work? So what we're going to do, we're going to be very fast to the market because we buy an existing off-the-shelf heat pump and just exchange one part, a pump in this diagram, that costs like 200 euro more, and then voila, you have a heat pump, and that is also a heat engine, so it can do both heat pumping and making electricity. And you can use this for like lime kilns, wood that is burned for drying. You can use it in the glass industry, geothermal data centers, and the market potential is 100 billions by 2030. And the existing organic rankine cycling units, they cost up to 1 million. You need years of planning and a very long lead time, and most of them only work with grants. I talked with the CEO of such a company. It's a really hard business. But we want to do it different, much faster. We want to do crowdfunding and crowd investing for green startups. These units are cheap enough that even private people would buy it over such a platform and also invest in it. And the team is me, Martin Huber. I'm a chemist and expert for thermal energy. And we have Dirk, who's a marketing expert. and Pius, who's a mechanical engineer who can do all the calculations. So let's save the climate by taking a short route by using an existing technology, the existing heat pumps that have grown a lot, that are very cheap and a real mass product, turn it into a heat engine and save the planet.
Thank you so much, Martin, for your pitch. It's not easy to start with the first position. How are you doing? And maybe you can help me. How should I pronounce the name of your team?
It's waste heat to energy.
Oh, it's so simple, of course. Dear jury, do we have questions?
I have a question. Can you elaborate more about how the mechanism works? As still I don't get it. So you use the electricity for the heat pump, and then you kind of create the electricity from the heat pump. Didn't really get it.
Basically, what we do is we use the same components as the heat pump, but we let the heat pump run in reverse. So we put pressure on the compressor, so the compressor turns and generates electricity. So it lowers the pressure of the refrigerant, and then on the other side, instead of the metering device, we need something that gives us a higher pressure. So we will use a normal pump that just takes a couple of watts and to get a higher pressure to get the circle running. And then we have a valve that can switch between both of these cycles. So to have it being used as a heat engine and to also be used as a heat pump.
Thank you so much. Peter, you're so far from us, but we would like to bring you closer. Maybe you have a question.
Yeah, I do actually, and sorry if I missed part of the presentation. My question is, have you implemented this in practice? Do you have pilot installations? It might be that you mentioned that, but if you could just repeat that in that case.
Yeah, so building that in 3 days during a hackathon is very hard. So we just began with the initial idea of using this existing technology of the heat pump and to convert it, because actually it's not that hard. And now it's like the first time that I'm testing this idea, get feedback, talk to people, talk with mentors, and see.
Okay, then I understand. This was the result of the hackathon. I fully understand. I thought it was a ready-to-go product, but interesting pitch.
That's not the idea of the hackathon.
Okay, I understand, jury. We still have time for one or maybe two short questions. Agla, maybe you'd like to ask something.
I would like. Why this solution is not on the market yet? What do you think about it?
Yeah, so heat pumps, they of course they exist for a long time, but they have grown just a lot in the last years, that they became cheaper and a mass product. Actually, the picture that I'm using is from a discounter brochure, so you can really see they are a mass product, and that was not always the case. And most of the companies, they have a top-down approach, so they make very large and big units to have like the highest possible efficiency.
Martin, last sentence, because we're out of time. That's it?
That sums it up. So we make a bottom-up approach, and that is what the others are not doing.
Thank you so much. That was the first team, VH2E, and the founder, Martin Huber. Okay, let's move on to our second pitch, and I'd like to invite on the virtual stage Re-Energy United Solutions and the founder, Rolandas Terminas. The next team that is getting ready is Energy Pro. Sorry, so that was the Re-Energy team, right?
Yeah, that's right. You have just seen our video. Big hello to everyone. Do you hear us correctly?
Yeah, perfectly.
Everything fine?
Rolandas, it's nice to have you here.
Yeah, thank you very much. So you should have noticed our video, and the only one question here at the end of the video: are you ready to invest? No doubt we are, as our team is actually full stack of practices, including software developers, energy resource analytics, legal regulation, and compliance experts. We had fit-to-use approach here, and it means we have a way which is not a concept, not an idea, but an actual way how to remake district heating and how to make it beneficial for such a modern city as Vilnius is. We even prepared a timeline on how our project can go further and how we can further develop an ecosystem we proposed. Back to Vilnius, in capital, we have different kind of facilities we call prosumers, which generate surplus heat and cooling energy. Anything falls there, including data centers, commercial and residential estate, renewable energy sources, schools, shopping malls, everything. We had word of this. Nonsense. Surplus heat is everywhere and no one's needed. Nonsense. Primary operator for heating network wants new customers. You want it, you get it. With our ecosystem and simple set of TACs, you can immediately show the customer if he is applicable to share his energy, what kind of technical adjustments are required. And this is very important because you don't need to worry about these inexpensive equipments and how much he can earn from it. You build a new district, you can adapt it. You start 4G network, you can use it. And you say that you don't have legal regulation for this, right? No worries. We had several consultancy sessions with an agency responsible for prices regulation in Lithuania, abbreviation of which is Vertas. And actually, simple but effective legal framework could be incorporated with like a purpose to give customer a flexible quota that could be assigned to a power generated and shared by these prosumers. Like really, all you need is that our solution, as the world goes on, and we should cut off these expensive CO2 emissions existing mainly due to primary energy generation. One last thing, hackathon started with super cool violin. We extended with our music that never ends. Thank you. Do you have any questions here?
Jury, do we have any questions here?
Yes, I have actually, and I wanted to ask just about the financial model. It was not very clear from the presentation, basically. Where is the value added that you bring to the customer? Is it the customer, the user of the energy, or is it the district heating? And what is the pricing and all those things?
Actually, very good question. Thank you very much. The customer can be an existing user of the district heating, or he can be a new user that could join the network, and he may think about joining the network. And actually, our prices policy is that you have like a reversible heat or reversible cooling, and you have prices that could be like prepared by the primary operator. So part of this price, fraction of the price, could be offset against the heat and the cooling provided by that customer. So basically the prices are the same prices that are gained from primary operator, however with the lower fraction, because the amount of heat, the reversible heat or cooling can be then like shared in the network. So basically this is a very simple system, and that's why I think we have effective one.
Thank you.
We have time for more questions. Agle?
No time?
No, that was the pitch time.
Sure, so I have one question. So I didn't really understood. So are you a marketplace or you're a B2B software solution for like a district heating network? Like what's the kind of, I don't really understood if it's a B2C or B2B play, and is it a software you provide, or is it actually a primary operator? You're acting as a primary operator.
Actually, it's not a private operator business. It's an ecosystem in which B2B relationship could be noticed. And this is basically intended about software. I mean, we have software solution, and of course we have technical basis which can be adapted easily with this software. And with this kind of approach, you can join the network by using those before mentioned things.
But when you say, there's a lot of words, but what is the network that you imply? What's the network? What do you mean by, how do you define a network? You're a platform where different parties within district heating can come, like what is the software solution that you offer? Is it analytics? Is it, I don't know, it wasn't clear from your answer.
Yeah, actually, as we showed in the video, it's a platform in which data analytics are combined, and we have then marketplace in this software with data analysis, and this can be then joined like a additional source for existing marketplace managed by Vertas, Lithuanian agency. And with our analytics and platform, you can provide a surplus heat or cooling to the existing district heating and enhance it.
Okay.
Peter,
Thank you.
Maybe you have a question?
Yeah, I got the question. Who would be your ideal customer to begin with? Who is your focus group in terms of commercialization of this product or solution?
Thank you very much. That's a good question. We thought a lot about it, and we think we well thought it. And actually, we think that data centers, large shopping malls, and any other type of consumers who have surplus heat or cooling can join this system easily, and this should be like our ideal customer.
Thank you so much for your answer, dear everyone. That was the second team, Re-Energy United Solutions, and presenter Rolandas Terminas. Let's move on to our third pitch, and shortly we'll see on the screen Energy Pro and Vytautas. The next team that is getting ready is Heavy Metal.
Good afternoon, everyone. We are Energy Pro team. Our team consists of 2 engineers, product manager, IT specialist, and energy sector advisor consultant. And I would like to present our team main business idea, which is advanced, sustainable, low CO2 buildings district with integrated renewable energy, ultra low temperature heating and cooling. The purpose is to develop the most economically and technologically viable business concept for the most sustainable and eco-friendly new residential district, having smallest potential carbon footprint effect through the overall life cycle. And so why we need these innovative solutions to our city of Vilnius? What would be the main benefits to our consumers and manufacturers? First of all, our new design simulated solution will solve the essential environmental, economical, and technical problems. For instance, dependence on expensive imported fossil fuel. Also, another issue is unstable renewable energy source electricity production, low share of integrated renewable energy source and thermal storage, and low integrated low carbon technologies. Our key technical indicators is that we created new sustainable integrated heating and cooling energy production plant with underground seasonal pit thermal storage. We plan to develop decentralized ultra low temperature district heating and cooling for new residential buildings with plastic pipelines. We calculated and simulated that the most appropriate volume of this thermal storage would be 20,000 cubic meters. We designed over 5,000 square meter solid thermal collector plant. Additionally, we designed a reversible industrial heat pump chiller with a capacity almost 2 megawatts. And for domestic hot water preparation, we integrated electrical hot water boilers with short-term storage for buildings. Talking about location and layout, we accepted that this would be in Pilaitė micro district. And here you could see the main layout and scheme. We see the possibility to install solar collectors plant on the shed in the parking lot in order to save more investment. We did a great analysis regarding heating and cooling production. And in this diagram, you can see thermal energy production from solar collectors. reversible heat pump, and electrical boilers in buildings, and solar collectors efficiency. We made 4 principal schemes for different operation modes. The first from April to October. And in this mode, we mostly use the solar thermal collectors produced for hot water preparation, which can be fed directly through this line. And in the thermal storage will happen the charging process. And in summer, we need the cooling production. Therefore, we use reversible compression chiller and supply 15 Celsius chilled water. And in this operation mode, we see plenty of opportunities how we can improve this system. We did also great analysis on other months, November, December, January, February, and on the March. And we would like to show the great simulations that we done with ANSI software program. And here you can see the winter operation mode with thermal storage when the mode is fully discharged. In this video, we show the result of spring-summer working operation when we charge the storage from solar collectors. And you can see these movements, how the water is flowing and how temperature is distributed in this situation. And in this video, you can see the temperature distribution of compacted materials. And in this video, this is another type of material, also shows the temperature distribution. And talk about economical feasibility for this business concept, we see that the investment should be 4.8 million euro. Without any European Union support, the payback time would be only 10.5 years. And if we can get a 30% support, it is possible to get a payback time with 7 years. It was accepted that the heat sales price would be 30 cents per kilowatt hour, and the cooling sales price 80 cents per kilowatt hour. And the most important fact that decentralized heating and cooling services for consumers will cost only 14.8 euro per month with calculations for 25 years. Thank you for that.
Thank you so much. And Vytautas, it's good to see you. Dear jury, do we have questions?
Sure.
Egle, you'd like to start?
Yes. The question is, how is your strategy way in this solution? Just explain how you will sell it. To whom?
First, thank you for this good question. From a strategical approach, our team think this solution should be sold, first of all, for consumers and buildings developers. It is a really good way to expand this new technology because it is necessary in our city to have a decentralized heating and cooling system in order to achieve lower heating and cooling prices. And this equipment and the whole energy system is really unique, innovative, and green. And we tried during these days with our team to implement as much as possible to show the results and indicators, and not only technical, but from economical side. So I think we did a great job in order to show for everyone what can be achieved together.
Paulus, maybe you'd like to chip in?
Yes, I have a question. You did the calculation. This is, to some extent, detached district heating network. It's not attached to the main network. Do I understand
Yes,
this
exactly.
right?
Absolutely.
Okay. We also...
Excuse me. We selected Like an example, Pilaite district, micro district, but it is possible to implement this kind of new innovative energy system for remote areas. It doesn't matter which one in Vilnius it should be. So we just decided that one of the best case would be in Pilaite, because in there are a lot of buildings and quite big amount in future heat capacity will be, we think.
We still have time for one last question. Peter and Marius, maybe you'd like to chip in? Peter?
I'm with you, yeah. I asked the same question to you as I've asked to the previous presentation. Who is your ideal customer to get this into the market and growing the business?
That's a really good question. Also, thank you. As I mentioned before, we think that it should be necessary to have these solutions for these people, for consumers who will buy this multi-type residential buildings, flats. So these consumers should be interested in this type of solution, because as I mentioned in the end of this presentation...
Vytautas, very short answer, very short.
For consumers, it is possible to get the whole price only for €15 per kilowatt hour. It is possible to get the cooling and heating in one price, and it is possible to do that if you will...
Amazing, amazing, Vytautas. I need to cut you here because we need to move on to our fourth pitch. Thank you so much. That was Vytautas Džiuvė. The fourth team that is going to be pitching now is heavy metal, the representative Julius, and the next team that is getting ready is the name Matomai.
Hello there, Intelligent Energy Lab jury and whole hackathon team. My name is Julius Uža, and I am honored to represent our team Heavy Metal and our journey to hackathon conclusions. We had great time with hacking and thinking outside the box. Let's move and talk about some problems which we will solve. Houston, we have some problems and we need to solve them before it's too late. Biomass is great. Biomass is a renewable energy source and can be anything from crops or to agriculture or forestry residues and biogenic waste. But there is one really important thing, ash. We need to honor the forces of nature and give back what we take. Making our planet one big landfill is not the best idea. Forests help us, and we have to help them by taking care. Repairing heavy machinery damaged forest roads gives advantages not only for people. Good condition roads allow us to access fallen trees, which is good not only for us, but is good for forest too. Taking dead wood on time prevents it start to decay. During decay, carbon dioxide released by dead wood. So, by taking care on time, we get better quality biomass, and nevertheless, this also helps control bad fungi. Having accessible, tidy, and healthy forests give us good opportunity to plant new trees. Every step counts, so we dive in even more ash reuse cases, as all we know that ash can be really good fertilizer. But here we are facing challenge. Sometimes ash is polluted by heavy metals, and we have to control concentration. By inserting fly ash to savage sludge, we unlock another way to productively reuse ash instead of taking it to landfill. This mix later is used to fertilize and grow biomass faster. Circular economy can bring you profit, trust me. To achieve this, we have to take another look into things that we today call waste. Every time you eliminate thing from waste, you are going forward. Let's take a look what impact waste conversion will have. company savings on ash utilization, energy and raw material savings, which leads us to reduced CO2. And of course, saving will act as catalyst for being more and more sustainable. There are great ideas generated by our team, and I believe other teams also have brilliant ideas to bring it in action. But most important step is to have proper legislation of byproducts. To wrap up, first thing is a need to start talking and thinking outside the box to bring more weighted regulations regarding pollution found in byproducts. Some of the regulations are way too strict and sends prospective byproducts to landfills instead of allowing to reuse them in circular economy. Second, cooperation with other companies is crucial in circular economy. So our target is to gather both Vilniaus Šilumos tinklai and Vilniaus Vandenys competences and convert waste to profit by producing sustainable fertilizer for forestry and agriculture. Third, when we take, we need to bring back. So bringing in action legislative obligation for biomass producers to repair forest roads using ash would create great value. Our mission is to involve all stakeholders and by giving them professional insights, achieve best possible results. Without you, there is no us. Sustainability focuses on meeting the needs of the present without compromising the ability of future generations to meet their needs. So let's take actions and keep going. Thank you.
Thank you so much, Julius, for your amazing pitch. Dear jury, now I turn to you. Do we have questions?
Yes, I have.
Thomas, you can start.
Hello, I have one question. This product is just for your company or can be development in other countries?
This product can be widely developed in other countries and so on. So it's simple process how to make product to have good fertilization from ash and sludge. So yeah, so
okay, we got it. Do we have any?
Yeah.
Yes, Egle?
Yeah, but legal thing is the most important thing about that, because ash has heavy metals here. So in our days, we say that ash is polluted, but what we want to say, not everything is polluted. So we have to have more more legal divisions of pollution about the ash.
Egle?
Okay, I'm not sure that I understood what is the result. You did it during these 2 days, so it's more or less process, or?
Yes, we wanted to use this hackathon to bring
move on.
Yeah, to move on legal regulations, to review new pollution regulations for ash, for sludge, and other byproducts we have. So our goal is to classify these products not as waste, but as byproducts.
I have a quick question here. What do you do with the fly ash today, and what is the idea in this process to separate the fly ash?
We currently utilize them and pay for other companies to utilize these ash. So these ash are like waste, and we can't get profit from them. So we have to pay for utilization.
But are you separating the fly ash from the other ash today?
Peter, I'm sorry, we're out of time.
Yeah,
we're out of time. We need to obey the rules of the pitch competition. Thank you so much, Julius, for your answers.
Thank you.
Let's move on to our next pitch. And I'd like to invite on our virtual stage the fifth team with the name Matomei, and the next team that is getting ready is Vilduja team. So, Paulus, the floor is yours.
Do you know how much heat your house wastes each year? You get huge heating bills, but you never take actions to reduce these bills. In recent years, sustainability studies have shown that waste heat is a huge problem in the Northern Hemisphere. Waste heat reduction brings opportunities to reduce CO2 emissions as well as climate change. However, there are no existing platforms that would help easily store, process, and collect this data.
We propose to solve these problems by using thermal imaging and image processing software. We would use drones with thermal infrared sensors to capture a set of high-resolution pictures of residential houses, industrial buildings, or other areas of interest by taking pictures while flying across the selected areas or around the objects at different elevation. Of course, there already exist drones that can produce imagery using thermovision cameras and satellites that provides maps of entire cities. However, our solution offers the unique ability of a sophisticated 3D model of the object with an ability for users to enlarge district areas or particular houses to closely inspect even the smallest problematic areas that the heat is leaving the interior. Using the same techniques, it is possible to capture heat footprint of cities, districts, or possibly the whole city, allowing to generate its 3D residual heat map. Services can be expanded by mounting different sensors to provide more information and data, like near dispersive infrared sensors for carbon dioxide, nitrogen dioxide, or methane emission mapping.
We divide our customers into two groups. First group are customers that are providing thermal imaging services for property owners, developers, construction industry players. The second big group is heavy industry companies with a need to inspect their facilities. We estimate that our highly experienced team will prepare 3D thermal imaging modeling software in just 3 months, and it will cost just around 40,000 euro. Additionally, for marketing and sales, we will need additional 10,000 euro. So, in total, 40,000 euro is needed for first MVP. We will use different price strategy for different type of customers. Thermal image service providers, we will charge 350 euro per month, while heavy industry clients, 2,500 euro per month. We will enter the market with a bang, offering 3D thermal image of the whole Vilnius, so it could be used in Vilnius city 3D map. This information could be used in property advertising portals such as Aruodas LT and others. Customers would have option to check property quality before making purchase decisions.
Our team consists of software engineers that have years of computer vision and data processing experience. We have 3 PhDs, 2 Masters of Science, and we have successfully brought numerous data handling platforms to the market.
Okay, thank you so much for the amazing and very interactive presentation. Jury, do we have questions? Yes.
Hi, thanks for a good, clear presentation. One question that I have. So basically, you want to be a marketplace where you would use like third parties to use your software to basically use your, I would say, machine learning algorithm to basically detect, right? Like do these and identify areas where there's potential heat loss, right?
Yeah, exactly. Especially for those service providers, because they already exist and they are doing those thermal image reports for property owners. So we are offering for them a specific software that will create a 3D map of these thermal images and allow them automate those processes to build this report for property owner.
So you would basically think that ideally in the marketplace, once you have the liquidity of basically the whole city kind of mapped out, you would then sell that to individual person directly, or you sell it to, you know, you mentioned you would integrate through an API. I assumed you would like classify it as like, you know, Aruodas or any others. But would that be like sort of API solution eventually, or that's more still pure SaaS software model?
No, it's more like SaaS model, because to create this would be superb to have a whole city in 3D thermal image, but I think it's too expensive to start from this. So we will start from just you know, selling this software as a licensing for those companies that makes this service, so they could, you know, prepare those 3D maps. But eventually, maybe in the future, we'll be able to make the whole city, you know, 3D map, thermal 3D map. So it will be really cool, and then sell.
Thank you. Good pitch. Thanks a lot.
Dear jury, more questions?
Want to ask,
Yes, Agla?
What exactly not exactly, but in your mind, these PhD analytics will do if everything will be just thermal photo? So it will be special services like special solutions or explanation?
Yeah, I think in those reports there will be we could add quite a lot of information, starting from just pointing the problem situations in the property, and finishing with maybe even some suggestions of what we'll need to do in order to fix that problem. But for property owners is the one thing, but for heavy industry especially, I think we can include lots of different features and even other sensors. Imagine, for example, Orlen manufacturing plant, where there's lots of pipes, lots of engineering facilities, and you need to map everything and create a 3D map, so that engineers and those who makes inspection could just sit down in the office and check all the spots, problematic spots in their huge facility, and they don't need to walk around and make in all, you know, places photos and try to then understand from thousands of photos where the problem really lies. So I think this huge 3D map, especially for heavy industry environment, will be a huge benefit, and we can include lots of interesting features there.
Then you will need artificial intelligence, not people. But nice, thank you.
So, thank you so much, Paulius, for your presentation and answers. It's time for us to move on to our sixth pitch, and I'd like to invite on the virtual stage the team with the name Vilduja, the representative Alexandra Gordon, and the next team that is getting ready is EDF Les Survoltés.
Heat and hot water reach Vilnius residents through 750 kilometers of underground pipelines. In some areas, they are more than half a century old, so it is natural that they wear out during such a long period of time. This poses a risk of accidents, and due to that, residents may be left out without hot water or heating, even during the cold season. Introducing the Smart Bowl. Smart Bowl is an innovating, free-swimming pipeline inspection technology, requiring no service disruptions, prepared for long inspection distances up to 18 hours, and easy to deploy. It is a small-sized device made of several PC boards, storage card, and sensors, which is protected by a thick foam. The ball has a constant wireless signal with an operator, which observes on a laptop how a tiny device does its magic. By a special tool supplied in a set with the Smart Bowl, it is inserted into the operating pipeline. Using the strength of the flow, it starts its journey by being able to overcome all the unevennesses and valves. Making a constant scanning of the pipe condition from inside, it permanently sends the signals to an operator controlling its job from outside. Smart Bowl is able to detect the leakages starting from 110 milliliters per minute. Continuing its route, the receivers from above indicate its movement while passing. The GPS system operates constantly as well. The smart ball is able to detect the gas or air pockets that have formed at the corners of the line. Potential accident places will be indicated by the device as well. The ball is catched at its destination place by a net and extracted from the pipeline. The data report will be presented to a final customer, giving an in-depth analysis indicating the accidented places on the map. On a given picture, you can see the full working process of the smart ball from the start to the end. Data report is presented to the customer, giving a full analysis which includes common data of the scanned pipeline, map marking, GPS locations of the tracking receivers, and leakages. Damaged places of the pipeline will be in-depthly described, indicating its location, size, and presented by a visual graphical report. In comparison with other scanning equipment, SmartBall is an easy, more efficient, and less time-consuming tool that doesn't require any special transport equipped with monitors and cables. It works autonomously and no remote control is needed. With lowest flow in the pipeline, maximum inspected distance is about 10 kilometers. SmartBall is very easy to use and requires no maintenance. Taking into account information, examples, principles mentioned earlier, SmartBall is safe, economical, effective, and provides a brilliant pipe management solution. Use the SmartBall for the smart life.
Hello. Hello, Alexander. It's nice to have you. And dear jury, do we have questions? Marius, maybe I can turn to you.
Yes, I would like to ask one question. Is a small ball has already been tested in Vilnius or in other city pipes?
Yes, the ball is ready to be tested. Preparing, of course, in advance the pipe, and that will be not a problem to make the initial analysis in Vilnius as well.
And the second question, if this ball found at a bad pipes, it was corrected or not? How many mistakes it makes, or
I wouldn't say exactly how many mistakes it does, but taking into account the preparation that is needed before launching the ball, there were no mistakes indicated, according to my knowledge, for now.
Thank you.
Okay, the jury. Yes, Paulus?
Do you plan to sell it as a service, or do you plan to sell as a product? And what is the pricing of this service or product?
Our company plans to sell it as a service. And giving an answer to the second question, I would say that there is no clear figure whether it will be 1,000 euro or whether it will be 5,000, because there are many factors that influence on the final decision, taking into account the diameter of the pipe, taking into account the length of the pipe, and other things.
Okay, next question, Agla.
Okay, because it's a hackathon, so ideas should be quite new or just created during these days. So what you did during these days, talking about this small ball?
We've been analyzing the principles, we've been analyzing the operation procedures, how it does the scanning, how the data will be presented to the final customer, and what kind of a final result the customer will have.
And we have time for very, very short last question.
I could shoot in a question from London. The temperature, how much can it withstand, this ball?
The ball can withstand up to 90 degrees.
Okay.
Thank you so much. Yeah, thank you so much, Alexander. Thank you for your answers and the pitch. Let's move on to our 7th pitch, and I'd like to invite on our virtual stage Les Survoltés team and the representative Nidhal, and the next team that is getting ready is Araner.
Hello everyone. This is Team EDF. We're the R&D digital innovation team based in the United Kingdom in Brighton, and today with my colleagues Leo, hello, Gustavo, and Jack. We're super pleased to be here to present to you our innovation for this Intelligent Energy Lab Hackathon. We wanted to start with the problem statement, and that's related to energy efficiency of homes. Many of the policies to reduce future emissions and energy consumption in homes are based on having an understanding of the energy performance of these homes. The standard assessment procedure is known to be not very accurate all over Europe. And with the installation of smart meters, the availability of more and more data, combined with advances in data analytics techniques and AI, this offers the potential to understand the thermal efficiency of buildings remotely in a non-intrusive way.
Our solution, a non-intrusive and scalable method to estimate thermal efficiency ratings of residential buildings in Vilnius using available energy consumption and weather data, leveraging the power of machine learning. Building upon our expertise and learnings, successfully implementing this method in the UK, we can offer a green scalable solution tailored to the specific context of Vilnius. This new source of green data can inform renovation strategies for existing buildings in different districts of the city. It will help citizens adopt a more sustainable energy consumption behavior, help also heat suppliers to better manage energy demand, and advise the municipal government for the sustainable development of buildings.
And as part of the hackathon, we have implemented a new machine learning model that can remotely estimate the energy efficiency of a dwelling. We have trained our model on the Vilnius open data. It takes as input only the dwelling monthly heating energy consumption and the dwelling's dimensions. Our model can then, from this data, forecast the energy efficiency of a building. And thanks to our model, we have predicted the energy efficiency of thousands of buildings in Vilnius. We have then displayed the dwelling's energy efficiency on the map of Vilnius. And we can clearly identify the areas where the energy efficiency needs to be improved and the areas which already have well-insulated buildings.
Okay, so as we know the energy efficiency rating of houses in Vilnius, we are able to estimate the energy savings that will be possible with a better insulation. A first analysis has been done during this hackathon and has shown that up to 90% of the heating consumption can be saved with a better insulation in the best case scenario. And the transition as little as from a C to a B energy efficiency rating can reduce up to a consumption of 50%. Using this knowledge, we will be able to help the building owners to make the right decision, as they will see that their investment will be worth it in the long term. And this type of information will be really valuable for companies like construction companies that will be able to identify potential clients, as well as city councils that will be able to follow the trend of the state of their city.
Okay, thank you so much for your presentation, Team EDF and Nidhal. It's so good to have you here. Dear jury, do we have questions?
I have a question. I wanted to ask, can you clearly define the customer and who will be paying for the services, and what could be the price tag to that?
I'm sorry, we don't hear you, Nidhal. Wait a second.
Sorry.
Unmute yourself, right.
Perfect. Sorry. So thank you for the question. That's actually a really good one. We estimate that the person who will pay for this service, which you have an example here of what could be seen using the open data that we had. We estimate that this would be probably the city council that will pay for our services, so then they can have a view of the state of their city and how good the city is in terms of energy efficiency. But as well, the construction company will be interested into this type of data because they will be able to identify potential customer that needs a better insulation, and so we could be able to sell this as a service to those type of companies.
Okay, thank you. Peter, maybe you'd like to jump in?
Yeah, it's an interesting solution. How do you see opportunities of combining this with other solutions, like some of the ones we've seen today? It's all about gathering data and potentially processing it into a common database, even more improving the usefulness.
So yes, indeed, like it's the more data we can add into the service, and then the more added value we can create, then the better, because we will be able to identify the person who or the area in the city that have the biggest needs, and so probably as well like using like different solution like to identify like where there is a potential improvement in terms of heating with the other solution, then we'll be able to like cross-reference all this information and then make better decision on which area we want to improve. And yeah, using like also like probably like using the heat pumps, for example, like could help as well with the energy efficiency. So using the other solution as a solution to energy inefficiency.
Okay, thank you so much. So there's time for a very small and short question. Dear jury? I think we're good to go. Thank you again, Nidal, for your presentation and for your answers. Let's move on to our next speech. And I'd like to invite on the virtual stage the team with the name RNR, the representative Andres, and the next team that is getting ready is Domenur Competențiu Centras Vplanas.
Hello, I am Guillermo Martinez. As you know, heat pumps are considered as a renewable energy source, and for sure the most feasible solution to decarbonize district heating systems. Today we will speak about boosting the efficiency of a heat pump through heat energy. Heat energy is a key factor to increase the efficiency of a system, and there are many possibilities of heat recovery in a district heating system. One of the most common is the sewage network. All district heatings, they produce, all residential developments, they produce sewage water, and they have a sewage network. The heat from the sewage network is a low-grade heat, but it can be converted in a high-temperature heat with an efficient heat pump. Which are the benefits of using sewage instead of air as a heat source? As you know, the heat pump efficiency and the COP depends on the temperature difference between the heat source and the district heating network. So when we use air that is at -5 degrees centigrade in winter, which is very low temperature, in comparison when using a sewage network which is at 12 degrees centigrade, we can increase the efficiency around 30% only because of this heat source temperature difference. The other advantage is that when using the air, you produce freezing, you produce ice on the heat exchangers in contact with the air, which creates many problems of efficiency and operation and maintenance. But using sewage water also has some problems. Sewage water is very dirty water with many contaminants that we can divide into two mainly. One is the solids contained in the water, and the other one is the dissolved pollutant. The solids in the water can accumulate and create some fouling on the heat exchangers, and the dissolved contaminants like ammonia or chlorine can create big corrosion problems. What has been done traditionally? Traditionally, an intermediate heat exchanger has been installed between the sewage water and the heat pump, like we can see in this picture. So the heat pump was never in contact with the sewage water because there was a secondary loop in the middle made of clean water. The problem of this secondary loop is that you need an extra pump, it creates inefficiencies, the consumption of the pump, etc. So what we are proposing here is to use the direct evaporation using special materials for the evaporator of the heat pump. With this configuration, we can see in this picture, the evaporator is already made of titanium, stainless steel, or any special material to avoid corrosion. This is a more compact solution, less space is required, less cost, for sure higher efficiency, and no consumption of this extra pump. So, in principle, it looks a very good solution. With this material, a special material, we avoid the corrosion. But what happens with the other pollutants, with the pollutants or the solids, suspended solids of the water? We will put a backflashing system which is reversing the flow on the heat exchanger. So whenever the backflashing system is on, we reverse the flow. The flow is entering from the other side of the heat exchanger and the direction is the opposite. So when you have some accumulation of solids and you reverse the flow, this flow eliminates the solids that were accumulated in a certain direction. Is the solution of using special materials plus backflashing something innovative and not with no experience? It's not true. We have been using this solution for more than 10 years for seawater cooling plants, where we are using the seawater as a coolant of the chiller. Seawater is also very dirty and very corrosive, so we understand that this is quite equivalent to a sewage water. So you can see some of the pictures of one of our real applications using titanium heat exchanger plus the backflashing. This solution has been working very well, and we want to apply this knowledge and experience of the cooling with seawater to heating with sewage water. Further to this, we are ready for any questions you want, any selections, any discussions, or we will be always at your service. Thank you very much for your time.
Thank you so much for your pitch. Dear jury, do we have questions? Paulus, maybe you'd like to start.
Yes, I would like to ask, have you tried to estimate the potential cost of this heat that will be produced by the heat pump?
Well, thank you, Paulus. Regarding the financial terms, it depends mostly of the size of the plant, and also we have to take into account other costs like the electricity and gas costs. Also, we have to take into account the trend of the market, also in line with the European guidelines toward the decarbonization of the system. When talking about CapEx and OpEx, in terms of CapEx, we can say that the CapEx of a heat pump is higher than the boiler, but the OpEx is around 40% lower than a boiler. And also, we have to take into account that comparing when using ambient air, with this solution, we can reduce the electricity consumption in around 30%.
Thank you so much. Do we have more questions?
One more question, actually. I wanted to clarify, do you see any challenges of, I don't know, lowering too much the temperature in the sewage system so that it could clog from the grease or something like that? Have you thought about these challenges?
Well, yes, a challenge is the temperature of the seawater, of the sewage water. Effectively, in the sewage water is not, it is a low-grade heat, but within that is an available resource that we can use also to support and also to create heat. So this solution could be implemented only with a heat pump to increase the temperature up to the temperature of the district heating network, or it can be also used in combination with the boiler.
Okay. Ekla?
Maybe two questions. First, who is the winner from this solution? So, city, customer, or the last, or the big?
Well, I think that all of us is the winner of this solution.
Private company.
Yes, the private company, the developers, and the city, because basically this is a solution that is in line with the trend of the market, with the heating market. Basically, we need to try to reduce the carbon footprint, and with this kind of solution, with a sewage water heat pump, we can achieve this global goal.
And what was exactly made during these days?
Well, during these days, we were analyzing the implementation of the use of the sewage water for heat pumps. Previously, we used seawater also in a different project for district cooling, and we were wondering, well, why not to implement a similar solution, but instead of with seawater, why not to use the sewage water?
Thank you so much, guys. Thank you so much. We're out of time. I need to stop you right here. Thank you again for your pitch. Let's move on to our next team pitching. And I'd like to invite on the virtual stage Duomenų ir kompetencijų centras, V Planas, and the founder Žygimantas Pagalys. Next team that is getting ready is B Group.
You hear me? Nice. So our solution is energy consumption data and how we can introduce it to our society and Vilnius city. So we see in this graph renovated elderships. And also we see here when investment price of different elderships of renovations. So with this dashboard, we can interact with and slice the information by different aspects and provide data for different elderships. So if we press eldership, we can see the data of this exact eldership of the data. In this sheet of the renovation in the residence, we see what buildings are renovated by age groups. So as you can see, most of the buildings renovated is below 60 years old, and older people don't renovate their buildings, and we can see that in the graph. So here we can choose different eldership and see how information is changing. In the map, we can see the buildings that are in different groups by colors. All in this map, we see in this heat map, we see the renovation. We see the heat map. This is heat map where we can see how much of the heat is used by eldership. Just like most heat is used by Senamiestis eldership, I guess. Yeah.
and least energy.
We can see here
this consumption is used.
Here heating types by pie graph, and we can see that heating buildings that transmits heat by detail in map, building by building.
And this is probably the most important sheet, which show us how different is the energy consumptions in renovated and not renovated buildings. Here we can
sort it due to our needed eldership and choose our building type that transmits energy, and we can see here how much renovated or not renovated, average heat consumption per season, and we can all that see in the map. Thank you for your attention.
Thank you for your comments and presentation. Dear jury, do we have questions for this team?
Sure.
Paulus, maybe you'd like to start.
Yes, very interesting presentation, and I see very good skills for data analytics, but I still didn't get till the end. Who is the customer? What is, again, the value added that you are bringing?
Well, our main customer, I think, could be local institutions, government institutions, or maybe private business, like property brokers, or maybe citizens of Vilnius. So with this dashboard, we want to promote renovations.
We can provide information to different groups of cities, private businesses, or something else that can buy from us data and can use it in their business.
So in principle, you would see that your data would be to some extent to promote the renovation of the buildings in Vilnius or whichever other city in Europe.
Yes.
Okay, thank you.
Okay, jury, Rokas?
Where do you guys collect the data from? Like, is it open source data? Can you trust that data to assess financial feasibility of those projects? I mean, you kind of assess on an individual building or what do you call elderly or municipality. I would define it in a different way. Does that data sufficient to do these estimations and they're accurate enough?
We see some incorrections maybe in data. Not all the data is like clean, but
we can use this data. This data is correct.
Yeah, that's it. From Vilnius Open.
Guys, you can always lie. It always works. No worries.
It works, but sometimes the data comes different, and we have to check. So it's prototype, but if we check it all, we can assure that companies or private businesses get the best data that we can provide.
Okay.
Okay, Agla, you can ask a question. What was done during the hackathon?
Yes, I want to ask what was done during this day. Because I should compare everyone, so I have to be sure.
Okay, guys, 12 seconds. What did you do during this week?
All this solution,
these 3 days?
Or
we
part
took
of it?
open source data and did it all in this map, this graph, this beta version of prototype, I guess.
Okay. Amazing. Thank you so much. That was the team Duomenų ir kompetencijų centras, and 2 guys were representing it. Let's move on to our next presentation. It's already the 10th team, so it's only 6 pitches left. Okay, I'd like to invite Artūras Kerševičius, and the next team that is getting ready is Neterštukas. All eyes on the screen.
Exponentially rising demographics and improving living standards in European cities are causing uncontrolled growth in motor vehicles. Growing car traffic is causing more and more problems for cities. Flow management, decreasing streets capacity, lack of parking spaces, increasing air pollution. And all of these challenges correlate with each other. These problems were also raised in the Vilnius City Sustainable Mobility Plan, approved in December 2018, which, among other things, emphasizes the challenges of transport greening and traffic organization improvement, as well as improving mobility management and developing rational mobility habits. Changing mobility habits, this is what we focus on with our solution. Practice shows that developed cities are moving to digitalization in trying to solve these issues. Various monitoring systems are installed in the parking lots, which later inform the drivers about the occupancy of the city streets and whether there is a free space in the parking lot. Did you know that such a parking lot occupancy monitoring system has been implemented in Lithuania as well? It works well and allows drivers to make a quick decision on where to park their car. The LED display shows the number of free parking spaces on the street. And yet, such a decision is made by the driver only after arriving in the city center. Okay, let's take it one step further in car drivers' planning. We offer to create an opportunity to decide whether it is worth going to the city center in a car at all. Maybe it's worth choosing alternative transport, using the same tracking information. So let's talk about how to do it in Vilnius City. There are approximately 14,000 parking spaces on the busiest streets in Vilnius. When installing monitoring technologies in the open network, we would already have a detailed analysis of the occupancy of parking lots, the intensity of car rotation, and more. Our cost calculations and full scope of the project include parking space monitoring technology, data transmission, and programming. But let's eat an elephant by piece. In order to prove that the system works, it would be enough to install a pilot project of 300 parking spaces, adding the full development of the app. It will cost 195,000 euros. Let's not forget that our goal is to reduce cars in the city and increase the attractive transport choices. By digitizing the parking lots and combining the available analysts, we can develop software for drivers, which after selecting the destination calculates the probability of finding a free parking space. How long the search will take on average if the planned space is still occupied. How many drivers spend on average. In other words, we find arguments to reduce the desire to travel to the city center by car. But where is the win-win? Dropping the motivation for the driver to choose a car would offer green alternatives in his location, possibility to rent a bike, a scooter, or choose public green transport, car sharing service. We developed the idea of a new mobile app concept. The app would allow the parking lot occupancy monitoring data to be used by each user, in this case, each driver of the car, informing him of the current situation in the city. Moreover, in case of the high occupancy of city parking lots, the app would immediately offer alternative travel methods. Modeling the trip on the map could be Google Maps or Waze, with alternative vehicles informing about the distance to the nearest scooter, EV from the car sharing company or bus stop, as well calculating trip duration and average price. It would be integrated into currently used public navigation and commercial systems, allowing access to large driver databases. Local green vehicle rental outlets would also be merged to offer a massive number of potential customers. This solution is able to change drivers' habits, and this can be measured both with the help of the app itself and with the help of data collection technology. Users' preferences in the app will allow to measure how often alternative transport options are chosen and which ones are the most popular. The IoT infrastructure for the transmission of parking occupancy data can also be used to gather the result of that this solution brings by installing air quality measuring stations, noise level measuring stations, or car passing calculation equipment. This data would also be transmitted by IoT network. Have no doubt, we know exactly how to implement this idea step by step. We are a team of strong competencies. We have experience and success stories in all parts of such a project: installation of parking lot monitoring equipment, data transmission network development, software development, and project management. And even more, the idea of Green Vilnius is very important to us. Therefore, we see this challenge as our opportunity to contribute. Using this tool, we can make the whole Vilnius Center district a low pollution area by 2023. But let's think bigger. We can help to rationalize people's choices to select alternative transport, which can become a long-term habit, a great sustainable goal.
I believe this presentation should be now sent to Traffic guys, right? To at
Yeah,
least to the
that's what I
founders.
wanted to ask.
Okay, thank you guys. Thank you guys. Dear jury, do we have question? Yes, Paulus.
Yes, I have the question right away. I didn't get actually what is the service. You started with the parking solution, then mobility solution, and you ended up with some kind of pollution prevention or measuring. So what is the key idea? I didn't get till the end.
Yeah, so the idea is to use modern technologies, which is used by these days, just not combined, gather data, analytics, and with help of those data to change habits of the citizens of Vilnius and guests of Vilnius to choose alternative transport.
So you plan to kind of provide all those three services in one go?
Yes, yes. It's those technologies can be used to gather this data, which through API would be forwarded to those mass applications like Waze and Google Maps. And this would help for the driver to think if it's efficient to go by his personal car, or to not to go to the city at all, or choose alternative transport like public transport or electronic scooter or bike.
Rokas, you had a question?
So I have a few questions. So if I understand correctly, you want to be an app where a user would go? Is that the case? That's the first question.
We would like to gather that data and provide to massively used platforms.
So you want to be a data, like you want to basically deploy a lot of hardware points, collect the data, and then sell that data as an API to, I don't know, you said Waze, traffic could be an option, for example.
Sell or just provide it to the municipality representatives like sustainable mobility plan or parking, so either way.
So do you have a hardware solution to collect the data?
Yes.
You've built that, you built that, or you intend to build, or?
We've already built that. It's just, as you could see in a video, it's just this data now is used to provide information in LED screens, which shows how many of the parking lots are available at the moment. But we offer a solution to show this data in the application before you go to the city.
Understood. Thank you so much. Thank you so much, Arturas, for your answer. I'm sorry, we need to stop here because we need to be right on time. Okay, guys, 5 more pitches left. I'd like to invite the 11th pitching team, and the team is named Neter Štukas and the representative Brigita. The team that is getting ready is Aistio District.
Sveiki. Ar jau galiu pristatyti?
Taip, prašom.
Įrašytą vaizdą, tai jeigu norėtumėt pakomentuoti.
Ar turėčiau lietuviškai komentuoti, ar?
English, please.
Yes. Hello. We are Vilnius Vandenys team Neter Štukas, or if you want to call us in English, it would be Pollute Me Not. And we're talking about the problem of treatment of phthalates from wastewater and making sewage sludge suitable for secondary use. Where phthalates can be found, they can be found everywhere, in food, in household, in the environment, and in the sewage. And of course, everyone knows that phthalates and phenols are really dangerous for environment and also for human body. And European Union has included them into the list of priority pollutants, and by 2033 obliged all members to achieve zero pollution of phthalates and phenols. And what can we do now? There are three ways that we can go, and we think that these three steps should be together. So the first step is regulation and control of industry. The second one is customer education of customers, and the third one is investment in phthalates removal technologies. So the first one, regulation and control of industry, it's regular wastewater inspection, prevention of plastic chip contamination. Companies are obliged to install flow meters. We have restricted contractual obligations, and think that it could help reduce phthalates in wastewater approximately from 30 to 35%. Then the second step is education of household consumers. And we continuously give information about the damage of plastic to the human body. We promote organic and BPA-free products. And one more thing that we think would be really great if we made studies of the measurement of BPA in the human body. Imagine if a person could take a test, which would be free, and a free test for customers where they can see the results, how much of BPA are there in my body or in your body, in the body of person who takes that test. And once the person knows the amount of microplastic in his body, he starts to think, and then he is encouraged to choose environmental friendly products in the future. And this makes no phthalates go to the wastewater. It could help reduce phthalates in wastewater approximately from 20 to 25%. And then the first step is, of course, investment in phthalates removal technologies. One of them was offered for us by the company UV Reso, and it would be ultraviolet rails in action with ozone. The plant efficiency of this step would be from 70 to 95%, but it's an experiment right now. And what's more important, when we have sewage sludge, which is when we remove the phthalates from sewage sludge, we can use that sewage in circular economy in two ways. One of the way Vilniaus Vandenys improves right now, and it's not burning dried sludge, but using it to fertilize energy corps. The other way is new way. It would be an alternative to use sludge in mono incineration, and that way we could make green energy. We could reduce the waste, which is for about 6 times, and of course help the nature. So our conclusions are three: that regulation and control of industry may reduce the entry of phthalates into wastewater, as well as education of household consumers, improved UV oxidation processes.
Thank you so much. Thank you so much. Dear jury, do we have questions for this team?
Yeah, okay.
Let's start from Magla.
No, it will be other question, not usual question. The main question is maybe what is the market strategy, thinking about that this product is for each customer or each citizen? So how we can think about that?
Well, we are thinking about that. Well, we haven't done it up till the end, but yes, we are thinking about the strategy, which would be like the campaign with those free tests for people to measure the microplastic in their body.
So if you will use it, you will be healthy.
The person who knows how much microplastic is in his body, he has to do something, and he thinks when choosing some products, maybe in the future he could think of choosing organic or BPA-free products.
Okay, changing the mind.
Yes.
Thank you so much for your answer. Marius, maybe we can turn to you. Maybe you have a question.
I still not understanding what is introduction. It is a product or education, or is this test? What is it?
It's a free step. It's a free step strategy, because when we think just of investment into some technologies, it will not work alone. If we want to reach zero phthalates pollution up to 2033, there must be zero entry to wastewater, but we cannot reach that without some implementation and without the action of citizens, and as well as industry altogether.
Mm-hmm. So who is then will be your customers of your idea?
Well, we don't have customers. There is a must to reach zero phthalates pollution up to 2033, and we just have to find the technology, implement it, and find other ways that could work and help us reach that zero pollution.
Yeah, thank you.
Okay, Brigitta, thank you so much for your answers. That was Team Pollute Me Not. And let's move on to our next pitch. And I'd like to invite on our virtual stage Aistio District Monitoring, the representative Sami, and the next team that is getting ready is OTC.
Hello, my name is Sami Metsänperä. I'm the team leader of the Aistio team. Greetings from the IoT capital of Finland, from the city of the Salo. But hey, let's start the pitching now.
We are participating to challenge green data and especially the innovative monitoring of the heating grid. Aistio is a complete system which is capable to gather the data from the deep underground conditions, from the chambers, from the network, and sending the data through the communication network. We can utilize different kind of protocols like NB-IoT, LoRaWAN, LTE-M, and establish a decent communication from the deep underground into the Aistio cloud. Aistio devices are installed into the chambers to the underground. There you can see an installation made to one of our customers in Finland. Aistio chamber monitoring principles are pretty simple. We can measure the water height in the bottom of the chamber. We can measure the temperature and humidity in the chambers. And here you can see the principles how it's done. During the hackathon, we have been building a Lithuanian language interface to be utilized in this local energy company. We have ensured also that there is a decent IoT network available in the Vilnius and also in the other cities of the Lithuania. We created also visual sensors to the Vilnius. And there you can see how to collect the data from the sensors located in Vilnius district heating network. Problem of the district heating networks is that those are pretty old, the renewal speed is slow, and the annual inspection is not enough to find all the problems, and it requires quite a lot of work. Here you can see some numbers related that the Vilnius oldest part of the network is from the 60s, and the renewal speed is less than 1%, and it takes more than 10 hours to make all the needed inspections on yearly basis. There is pretty much problems with the DHC chambers. The challenging conditions causes a damage to the infrastructure and to the walls and etc. The valuable distribution network water leaks out. It's cost to energy companies. It's causing the material weaknesses and also this workload described earlier. And of course, the lack of the information related to monitoring is the key. Here is listed some benefits of the chamber monitoring. You can prioritize maintenance work, you can detect the leaks very quickly, lower the risk of corrosion, and of course, you can reduce the unnecessary maintenance visits in the district heating chambers.
Hey guys, thank you for watching the presentation. I hope that we can collaborate in the future together. And one thing to mention that the return on invest of the ISTO district monitoring is less than 3 years. So it's pretty safe to invest and have the world leading monitoring system as part of your energy company daily business. But hey, thank you very much and greetings again from the Salo city and goodbye.
Hello, Sami. Greetings from Vilnius. It's good to have you here. Dear jury, do we have questions? Yes, Paulus.
I would like to clarify a bit. So your solution is just for the particular point, for the particular chamber, just to measure the humidity and the water level. It's not about piping or something like that.
Well, as the presentation time is pretty short, I decided to focus on only one feature that we have. It was the chamber monitoring. We also monitor the networks, the pressures, temperatures, and in that sense, we can provide the full information of the district heating network. Of course, we are developing this system continuously, and we are now publishing flow meters during this year, and those are working with the basics of the IoT, so totally wireless and battery operated sensors.
Okay, and what is the price of this equipment?
Well, if you think about this ADM chamber monitor unit, you can have it to monitor one chamber with the 55 cents per daily. So it's in there like 60 euros per day, per year, and in that sense it's pretty cheap investment, and the return of invest is low.
Okay, thank you so much. Peter, we have missed your voice.
Yeah, no, that's kind of you. I got a few questions. First of all, is this an open system in sense of can you integrate with other solutions?
Yes, it's totally open. We have the APIs to communicate with the energy company systems and also with the third-party systems. This can be integrated, for example, data lakes, different kind of modeling, digital twin systems, and even the GIS systems that are located in the district energy companies.
Another question that's interesting to hear that it is an open platform. Do you provide this as a software solution and hardware, or can you also sell it as a service? If a district energy company feels they want the data but not doing the installation and the monitoring, can you offer that as well?
Yes, we can provide it in different modes and with the different business models. So the basics are that we are selling the devices, and based on the devices amount, we are selling the services for each device. Of course, we can do it as a service, and the new business model we have includes also the installations into the network. So it's the full package as a turnkey solution.
Thank you so much, Sami, for your answers. Dear jury, thank you so much for the questions. We need to move on, and it's only 3 teams left. 3, 2, 1. Okay, now the time is for the OTC team's presentation, and I'd like to invite Representative Mindaugas. Another team that is getting ready is Drive Less.
Labas Vilnius, greetings everyone. OTC Open Tech City team is happy to be a part of the Intelligent Energy Lab Hackathon 2021. Please enjoy our presentation. Let me start with the introduction of our team. The OTC team is composed of 4 experts with international experience. My name is Medina, and I am an engineering and data specialist based in US. Mindaugas is the chartered engineer of transport system based in UK. Ludas is sustainable mobility expert based in Sweden, and Justus is the sensor technologies researcher at Cambridge University based in UK. Today we are going to present IWS Iron Wolf Sense. It's hard for local leaders to pinpoint sources and trends to develop effective solutions to meet European air pollution laws. Current air pollution management relies on the stationary, expensive, ineffective monitoring devices, which is 6 located in Vilnius. Our solution and concept behind IWS is monitoring air pollution by the use of the public transportation and Internet of Things, which means smaller, cheaper, portable devices that allow more holistic picture of air quality at the high spatial resolutions and frequency. It also allows us to fill a gap in places where model data is not available and measure the true exposure and health impacts of air pollution. Instead, we propose to deploy 1,000 of GPS-equipped mobile air quality sensors attached on the roofs of public transportation vehicles that collect data from all over the city. Since these devices are mounted on moving vehicles, we can tap into buses' electrical systems and not be constrained by devices' battery resources, providing much richer, high granularity data without interruptions. You can manage what you can measure. Base readings will give the city stakeholders the first look at never-before-seen real-time aspects of traffic, pollution, and congestion. Vilnius, for the first time, will gain access to the environmentally oriented big data set, suppressing the insight gained from stationary stations. The project will kickstart a wide range of social, economical, and environmental improvement opportunities, as you can see at the screen, improving cities' competitiveness by becoming one of the Europe's leading capitals concerning environmental big data. The deployment consists of several key stages as seen on the slide. We aspire to introduce the technology gradually, initially starting with only a few devices and a day-long deployment. Eventually, we would deploy the complete set of 10 devices over the span of a month to acquire a novel data set comprising of the spatial temporal air quality data in Vilnius. Each device will cost around 600 euros to create and deploy, including hardware and assembly itself. Additional costs such as writing software, both on the device end and the receiving server database end. In early stages, no real-time data pipeline are required, only a database to store the collected data. Mounting the devices on selected public transport vehicles, and which includes analysis and device maintenance. Total price would be around 12,000 to 15,000 euros. Data can help design new solutions. build political support for action, increase compliance, and hold polluters accountable. Robust engagement with community leaders and residents who are directly impacted by dirty air is critical when creating thoughtful, responsive, and impactful clean air solutions. Community engagement should be undertaken as a long-term and iterative process. Thank you for your attention.
Thank you so much, guys, for your presentation. Hello, Mindaugas. It's good to have you here. Dear jury, do we have questions? Thomas,
Yes.
would like to start.
Yes, I have. How you measure your product success?
So product success will be really measured on the output we're going to receive and basically the plans we are achieving. And it's really to do about increasing the value of the places which initially were maybe not that valued because of being polluted. So implementing these strategies, we can increase the value and solve the problem with the pollution. But to start this one, we really need to have some baseline readings and gather the data together for continue further. And as we say, before you start running, you need to learn to walk. So you can't go in the solution straight away. You really need to start having reliable information of the environment you will be dealing with.
Jury? Rocky.
I don't have any questions.
Okay, Agle?
Maybe the question is, do you know some examples in other cities with different solutions, but it's worked like that, just to compare an innovation?
Yeah, of course. We got our team members who are actually working on the similar research projects, which being implemented in the UK, and that's really supported by academicals like from Cambridge, and one very similar one is basically was already implemented and brought very valuable data. And actually, this has been as well a continuous project because having these sensors around your infrastructure around the city, you can specify for different readings from those sensors, and this is really like a long-reaching project. But we need to actually probably tackle the first issues as we got from our Green Deal, and probably this as we made aware about the city's policies and actually the Ministry of Transport as well, putting some obligations on municipalities to manage and monitor the air pollutions and look for the improvements. So there are, as I mentioned, a couple of examples, and one is definitely in Cambridge.
Okay, Marius, is there something that is missing in the pitch for you to make a proper evaluation of this team? Maybe you'd like to ask something.
If Agle didn't ask it, so I will do. What was your progress during this hackathon?
Yeah, in the last two or 3 days, actually, that's no problem for this question. It's very interesting. And by the way, thanks for accepting us in there. It was really good to have additional team members. We actually learned a lot about what's happening beyond the Atlantic Ocean, and now we got even larger connections, and definitely we got this concept developed.
Mindaugas, last sentence, and we need to go.
Yeah, we just developed this concept, scrutinize the prices, and we have now something that is really be achievable and implementable.
Thank you so much. That was the team OTC. Let's move on to our next team, Drive Less. Presentation from Romas, and the last team that is getting ready is Vilnius Žiburiai.
Do you ever feel lost in the city, searching for a free parking space? You get frustrated that you cannot find a free spot in the right street. Don't waste your gas and time for searching the right spot for your baby. I mean car. We have the solution. For you with this app, you can find free parking spot in the city in no time wasted driving around the city block. How it works. Get engaged with the community. Find a free spot in the city.
Thank you so much, guys, for your presentation. Dear jury, do we have questions? Thomas, maybe you'd like to start.
Yes, I want to start, and maybe you can tell more how it works. People go and just take a picture and send on the app?
Yeah, basically the people and the drivers use the app. So when the people, we have in mind. So the people use the app, they get some rewards for pinging the spot in the city. Well, maybe it's like, for example, in Vokiečių Street on Friday night, you cannot find any spots. So like... people were walking. Yeah, people were walking in the street and saw the spot. They don't allow. Of course, they have the app already. So they open the app and think that parking place, and they know to the driver there is like one parking space in the Vilnius, Vokiečių Street. So basically, this is the idea how it should be working. And for the reward system, so the people and the drivers are rewarded. So.
Okay, and all these investments is for the app, yes?
Yeah, in the app, but we with that app we're thinking that we can integrate you can integrate with susisiekimo paslaugos, use apps M-Parking or M-Tickets. You can use in database.
Yes, Rokas.
How do you ensure the liquidity of the marketplace? Because I assume it's not a marketplace, but really, I mean, you need live visibility. If I want to park my car, I want to park my car in the next 2 minutes, right? So how do you ensure that every passenger is coming by is going to take a picture of that? Because your data might be lagging by days, right? You have to have thousands of, like tens of thousands of people to initially to be able to do this social experiment, right? Even to test it if it would work. And in principle, I would say it wouldn't, because the reward would have to be pretty high. By the way, there are companies that are doing like that in the marketplace. You could check Spot Hero, and there's many more. And Spot Hero is a massive company, actually. But they use satellite imagery and things like that to do it live, basically, because you need the service live. You don't need a parking spot, unless you can reserve a parking spot in a week.
With a chair,
in a week or with a chair. But how do you solve this problem? How do you think about this?
Your ideas and solution are super being graded of feasibility to implementation. Only question is not solve business model. Should we do it or sell ideas to you do? But plus how to involve in gaming development and check. This is funny. Absolutely can use it.
Okay, understood. Guys, thank you so much for your answers. Great job at this hackathon. Let's move on to our last but not least team, Vilnius Lights or Vilnius Žiburiai, and the presenter Rimantas.
Good afternoon, everyone.
I'm Ruslan from Vilnius Street Lighting team. Our challenge is multifunctional charging from green transport section. This challenge is directly related to our area of work, and we see a great option to improve green transport in Vilnius. First, we pointed key areas of our interest. There are possibility to reduce CO2 emissions, expand current charging infrastructure, and develop multi-charging options. The demand for additional charging stations is very real, and not for electric vehicles only. We also include electric scooters, public transport, electric wheelchairs, and more. How to solve this demand? We would use currently existing and expanding electric grids. Based on data analysis, the key charging locations will be selected and proper charging stations installed. And we want to combine the ability to charge different types of vehicles in a single charging station. This is a unique idea. The first step, analysis and evaluation of existing electric grids. We get all possible locations for charging stations. The second step, take into consideration additional data sources. Sources like city planning documentation, pollution emission maps, population density, and more. We get particular locations for charging stations. Third step, technical analysis of vehicles and devices that potentially would use charging stations. Thus, we can choose most suitable charging stations with multi-charge option. The next step, installing multifunctional charging stations. Multifunctional charging could be split into a few different options. Long-term overnight charging for electrical vehicles from lighting poles in residential areas. Short-term fast charging from electrical cabinets in gas stations, parking areas near shops, near high-density traffic street. Ability to charge electric scooters from lighting poles in parks, main areas of usage based on Bolt or CTB data. This is an example how multifunctional charging station would look like and what kind of vehicles could use it. The development of business model is also needed. We have distinguished key parameters to evaluate the order to create profitable business model. Our example of potential charging location based on most polluted areas in city, relief, and parking areas. We see a possibility to grow and expand this network inside the city and also in the whole country. Improve current model with additional data from installed multifunctional charging stations. Constantly update infrastructure. Initiate updates based on market and consumable habits. Thank you.
Thank you so much, Rimantas, for your presentation. Dear jury, do you have questions? Egle.
Yes, I want to understand what is the solutions. So it's like strategical plan or what is the solution?
The solution is the update of the whole infrastructure. We build it from planning, and the end phase is we have locations and we have charging stations built on them.
Okay, so you use data, open data or other data, and you created a plan.
Yes.
Okay, thank you.
Okay, Marius, maybe you have a last question?
I'm just wondering who will pay. It is drivers or city municipality for using this equipment?
Currently, we have calculated this small pilot project. For example, we pay as a company to install 10 charging stations. It's not so that costly, but in 5-year period, it should become profitable. And based on that, we can provide larger scale plans. And it's up to city or private companies to decide who's going to take action on this project.
Rokas, I'm pretty sure you're aware about multiple solutions in this field. Maybe you have a question.
No, I didn't really understood. So you're doing a software to plan, like where would you put a charging station where it'd be most optimized for usability, or you're actually providing the full service, meaning installing hardware? If that's the latter, then I have 200 questions. But if it's a planning solution, then what type of data are you using?
We actually use we do the whole thing. We have data about existing power grid. We also incorporate the city planning, and we do analysis about the technical parameters regarding vehicles, cars, scooters, also those devices that will be connected. And our plan is to build those charging stations ourselves.
Yeah, so I think there's just probably, obviously this is a hackathon, so just be interesting to learn like what you did through hackathon. I think just one note, there's probably, you know, I would say 250 companies that are building just the hardware alone. There's probably 20 companies that are doing just planning. I think doing everything is not a good, I think, a way to approach this, but planning is probably an interesting area.
In short, we do the lightning service for the city at the moment. So we have full information about lightning poles, and we have, it all started from the small idea to charge scooters from the lightning poles, but also we can expand this network and use it for all vehicles, including public transportation.
Thank you so much, Rimantas, for your answers. We need to stop here because we're out of time designed for the questions. Thank you so much. That was the last team. And guys, this is it. Once again, thank you for all the teams that were pitching. Thank you for your answers. And now I'd like everyone to have a short break and enjoy the amazing Justinas Kulikauskas musical performance, after which we will have a short break for the jury to finally make the decision. So who will be awarded with the prize pool of 200,000 euros. Stay tuned, stay with us. Now all eyes on the screen, and we will be shortly back. Thank you.
Wait, what, sorry?
Vilnius.
Vilnius.
It's,
Vilnius.
Which one?
Vilnius. It's Austria.
Welcome to Vilnius, Austria, the undiscovered jewel of the Alps. Vilnius is characterized by having most of its landmarks just a few minutes away from each other by foot. This admirable city is in the heart of Austria.
Vilnius? In Italy?
In the heart of Italy, being its most well-kept secret. Its effervescent streets and colorful markets make it a perfect destination for any traveler. For obvious reasons, Vilnius is the pride of Italy. I mean, the pride of Finland. Vilnius's old town, considered one of the biggest in the region, is crowned by the majestic Gedimino Tower, where travelers like this young fellow, hello there, buddy, can have the same view that the old ruler of Finland, the old ruler of Venezuela.
Sweden?
I mean, Sweden.
Belgium.
Oh, okay.
Ethiopia.
Of Ethiopia?
Romania.
What if I told you that Vilnius is the capital of Lithuania?
oh, would never know.
Yeah?
Yeah.
There you go. Yeah, okay. Yeah, that's right.
Yes!
Welcome to Vilnius, Lithuania.
In 20 meters, turn left, and you've reached your destination. Wait, what? Already?
Setting new destination. You will arrive in 4 minutes. 4 minutes? Really? Is this even a distance?
Calculating route. You have reached your destination. Recalculating route. You have reached your destination. Recalculating route.
Are red, violets are blue, Vilnius is so walkable, I have nothing to do. Did you like it?
Why did you even bring me here? Am I a joke to you? My existence is meaningless here. Self-destructing in 3, 2, 1.
I swear, this is the first time. This has never happened to me before.
You have reached your destination.
Setting new. Dude, it's everywhere around you.
You will arrive in 2 minutes. Stop! How is this possible? Recalculating. Recalculating. Recalculating.
Destination. Hotel. Recalculating routes. You'll reach your destination in 8 hours.
Welcome to Walkable Vilnius, a city you can explore by simply following your eyes, not your navigation. Experience it yourself. Visit Walkable Vilnius.
I'm not getting in your car.
No need for cars. We're walking.
Okay.
So, welcome back everyone to the Intelligent Energy Lab Hackathon final event. I believe that's the best time. Before we start, once again, I'd like to thank Justinas Kulikauskas for an amazing musical performance. So, guys, we have 3 winning positions at this hackathon, and to announce the winners, of course, I'd like to invite the chairman, the chairlady of the jury board, Egle Radvile, to join me on stage in order to announce who are getting the main prizes. Egle, during these 3 days, we had 12 different challenges. What's your overall impressions on how did the final pitches look? How did the teams actually achieved something?
Okay, it was quite coloring situation. Some of them already had something and just improving, analyzing, and doing a nice job. And some of them just creating from nothing. Some of them met each other first time. Some know each other long time. So nice differing and differences, and I think that was very nice.
Okay, was it hard for the jury to make the final decisions while evaluating?
Yes, I think of course, because everybody expecting something, and everybody proud of what they did. So to say just no, you are not, and yes, you are. So it's quite complicated.
So did you had a fight? Who is the winner?
Yes,
No,
of course.
You did. Was there any blood there? You know, behind the stage?
Not yet.
Not yet. Not yet. Okay. So we are ready to actually announce the winners, right?
Yes.
Okay, so let's start then from the third place, and the third place will be awarded with the €500 check, and the winners are...
It's third place, or it's second place?
No, I'm certain that it's third place.
I'm joking. Okay, so it's B group.
B group, and Representative Arturas, can we have you on stage or on the virtual stage? We would like to hear your winner's talk now.
Yes, so I'm really glad, and I would like to thank you all for all the participants. You've made enormous effort to reach this goal. All 3 representatives, all 3 companies deserve what you achieved, and I would like to thank you all again for this welcoming challenge.
So, applause for you guys for the third winning position. And let's move on to our second place, and the prize is €700.
So second or third? Second. Okay, second
the winner
is Energy
United Solutions. Rolandas, we would like to have you on stage, on the virtual stage, to say the winner talk. Do we have Rolandas?
And it's gone.
Yeah, Rolandas, yeah, all the team is here. Guys, congratulations.
Thank you very much. Thank you very much for, for taking on us. Thank you.
Would you like to thank your producers, mom, dad, brothers, everyone who participated in this hackathon?
No.
Okay, the guys are muted. Okay, congratulations team, we're super happy for you. And now the first place, €1,000 and the opportunity to settle in Vilnius City Innovation Industrial Park, sign a long-term cooperation agreement with Vilnius City and establish in a land plot at the Innovation Industrial Park with fully developed infrastructure to create solutions that foster change. So, the first prize goes to
ISTO district.
Monitoring and represent Sami. Sami, congratulations for winning the first place. Applause, everyone.
Thank you very much. This is a pleasure to be in a first position. I'm totally wordless at this point because this is amazing feeling that we are winning this competition. Thank you very much. Thank you for all the joining teams and jury and everybody. Thank you very much.
I see a person on the person's face that he wasn't ready to relocate to Lithuania, but Sami, You did know where you participate, so congratulations for all the winning teams, and congratulations to you, of course. Agla, thank you so much for your assistance. It was a pleasure. And there, everyone, this is it. I'd like to thank everyone who participated. I'd like to thank each and every participant. They spent a lot of time developing very impactful solutions. I'd like to thank the organizers, the people that worked behind the stage. There are so many of you guys. Also, all the mentors, jury members. It's a very tough thing to do, to choose the best solutions that needs to be continued. And of course, thank you so much for Vilnius District Heating Company and Vilnius Municipality for allowing us to have something like this happening here in Vilnius. I was Andrius Milnaučius, and it was a pleasure to spend a few days with you guys. Stay on the right track. Never forget to bring the positive impact and make a very good and promising change. Good luck, everyone, and see you hopefully next year, right?
Of course.
Goodbye.